All right, I know we're running behind, so we're gonna just dive right in.
Sure.
So I'm very excited to be speaking with John this morning, and I know one of the things that that came up yesterday in some of the sessions, and I know we hear this broadly, is there's a lot of questions around AI and what's myth versus reality. And clearly we are at an MIT AI conference, so I'm assuming most of the people here believe that there is at least the promise of reality now or in the future. But John, your company is actually doing AI in healthcare today.
Yes, we are.
And so I was going to ask you to just kick off and just tell us a little bit about Arterys. What do you guys do? What are some of the problems that you're actually trying to solve today?
Sure, I'd be happy to. So Arterys was started back in 2013, and we really started with this idea that we wanted to do data-driven medicine. And basically what we built today is a medical imaging cloud platform to be able to help radiologists primarily to identify, track, and really support in the both in the diagnostic and therapeutic process. So our first products are actually in the MRI and CT space. So we take images from MRs and CTs, and we process them to be able to identify disease, quantify the images, and be able to provide basically automated reports for radiologists to see, to validate, and to be able to push back into their reporting systems.
Fantastic. And so I think to unpack, because you have a lot of different components to what you just said, and especially in healthcare, as you know, it's not just about the technology, it's about how do you actually bring those tools to clinicians and to patients and incorporate it into workflow. Mm-hmm. So can you just walk us through some of those components a little bit in more depth, and just also how you're actually incorporating AI into it? Because I think there's technology, there's analytics, and then there's actual deep learning AI. And so how are you incorporating that today?
Sure, I'd be happy to say. So first, I'll mention that so we use deep learning for as much as possible. That's the fundamental technology. But there's so many people starting to use this in research, or there's people who are just hackers that are just downloading public data sets and creating amazing models that are very accurate. I can say that they're as good as experts at doing a lot of things. And like in pathology, radiology, areas where there is a lot of data, it makes complete sense. But going from that to an actual product in production, making revenue, is such a big leap. And I can tell you that we've been trying to do it for the past 5 years. And so part of the things that we've been able to do is, yes, the actual model making process is a couple months. It's actually not very difficult. People can download TensorFlow, they can create models. That's not the hard part. The hard part is working with legacy infrastructure, to try to embed these AI algorithms into the clinic. And that's proven to take a very long time. And so the one way we've been able to do it is integration with OEM vendors. So we have partnerships with 2 out of the 3 largest MR manufacturers, and we work with their development teams to embed our technology with their machines to make it seamless. We try to use open standards as much as possible to communicate AI to the different systems. So in imaging, it's DICOM, there's HL7, there's different protocols that can be used. We also spend a lot of time on security, privacy. So we've had to basically build out an entire infrastructure to de-identify images prior to them leaving and going to the cloud. Because part of the difficulty with trying to do AI at scale is we need to collect data. And in a lot of jurisdictions, they just don't allow you to do that. And we're regulated in 30 countries and expanding. In every country, it's a challenge to extract data, to learn from that, create models from that data. And so we spend a lot of time in that infrastructure to de-identify, run the models, either training or inference, and pull the data back in. And from a user experience perspective, the actual clinician actually sees patient names within the web interface. So it's actually sending multiple commands to both our servers and servers in the hospital to be able to have that experience. So that's just a couple of examples where we spend a lot of time and money to be able to embed AI into real clinical workflows.
And how are you finding it working in the clinic? How do you feel the providers have responded?
Yeah, so I'll say there are two types of companies that do AI for healthcare. I'd say there's, at least let's say in imaging, there's the type of company where you send data and it sends back a report. That's one category. The second category, which is the one we're in, is you send data to the cloud and the physician actually logs in and validates it, and it's basically an interpretation platform. So we're in the latter. So what we try to do is try to automate a lot of the tasks that they're doing that they hate doing, versus the idea just to be able to say, yes, this scan is cancerous or not. So we give full control to the physician through a UI. And I think that's been our kind of key to success, is because, again, we're not trying to replace them. We're trying to actually just remove that repetition and like things that they hate doing, like annotating, drawing circles, trying to find things through a stack of 100,000 images. It's very hard. So that's been one of our kind of game changers. And the other piece is, I think people like, like people love the fact that it's there, and when it's not there, they complain. But when it is there, they enjoy it. But it just comes so naturally if it's embedded within the UI. But if it's in that first category to say, hey, that we're just giving you a diagnosis, it's hard for them to really validate that unless they see the actual raw data.
Have there been any surprises as you've started to roll this out? Anything that was unexpected?
Yeah, there have been. So what we've seen is both in training models based on certain demographics of patients. In the US, we can get kind of like a global model. But what we've seen is certain institutions like to do things differently. And so, like I mentioned, in the 30 countries where we're live, there's organizations, health systems that completely like to do things a completely different way in how they measure the size of a nodule or how they measure the volume of their ventricles. And so that's a challenge, because that means we need to create personalized, or not really personalized, organization level models and train using their data and provide that at scale from the cloud. So that's been one of the challenges, is trying to, and it really shouldn't be like that. Really, there should be a standard way as to how everybody does something.
Sure.
And so what we're trying to do is kind of work with societies to really get the same standard. And it's not there yet from a quantification perspective. Yeah. And we're pushing, like we're lobbying for that, because a patient is going to go to multiple health systems, and it should, if they're going to have a scan read at one place, the number should match like in another place.
Same experience.
And it's not right now.
Yeah. Well, so then help me connect this to one of the points you mentioned before about how you actually get de-identified data coming through. And so it sounds like actually getting some of that patient demographic information is important inputs into your model. So how are you balancing what data to come in even in a de-identified place that will actually still get you accurate results?
Yeah, I'd say that the US is actually the easiest place to do that, because you can sign BAAs. Shockingly.
Never heard the US be easy.
Yeah, so you can sign business associate agreements and get raw data. And yes, as long as you have enough liability insurance, you can work with that. The reality is that there's so many different countries out there that just don't allow you to do that. There's much stricter laws around that. So we've been lucky so far that we've been able to build models using just the de-identified information from either an HL7 feed or from DICOM. Yep. But the reality is that that's going to have to change. And so we're going to have to change the architecture a little bit to try to bring some of that information into the cloud. And we initially didn't do that because it was such a huge leap, just the cloud. We started with that in 2013. And we would go into these security reviews and say, no hell in way we're going to do the cloud. And that's changing really fast. And like now we're going into security reviews and saying, okay, yeah, one of the companies done it before, we're open to it. Here's this like different set of documents. And I think people will get there eventually in different countries. But we've been lucky. We didn't have to do that yet, but it's coming. Especially we're going into this idea of predicting outcomes and predictive analytics and combining imaging with different types of data. And that's where we'll really need to get into the nitty-gritty of using genetic information, information from the EMR that is really personalized. So we're definitely heading in that direction.
Heading in that direction. So is that then one of the requirements for actually launching your platform, is that they must be collecting a minimum set of information about these patients and consistently collecting this data?
Yeah. So what we try to do is we try to do all the work, because if we're reliant on them or their IT departments to do anything, it will never happen. So, like in fact, we're going into sites where their entire IT team of 10, 20 people is just working on Epic installations, and there's a queue of 100 companies that are just frozen in time. So, if you can just say, hey, it's zero-touch serverless deployments, we'll do everything. All you need to do is configure a PAX endpoint. That's what we try to do. Right. So that's why we had to build out the infrastructure to supply this PHI service and be able to just have less touch is actually more. So
Yes.
that's been one of the challenges, just the sales cycle and the install process. It's been very, very long.
Yes, I can certainly appreciate what you're saying there. Healthcare in particular is an industry that I feel like a lot of technology folks have run away from, although I'm excited to say more and more folks are actually entering the space, which is going to be critical. Yep. And so one other question is, when you're talking about how do you actually have AI become a clinical product, can you talk about that process?
Sure.
We heard in one of the sessions yesterday that working with the FDA is a nightmare. So talk a little bit how your journey in that.
Yeah, so we're one of the first companies to actually get an AI algorithm approved by the FDA. This is back beginning of last year. And I think that they've really changed their tune just in the last couple of years of working with companies, embracing AI. There's been a handful just recently in the past couple of months that have done it. And it's great to see. It opens the door for all of us, which I think it's great technology. We should all be doing it. So they're understanding, they're learning. There's also questions around when you retrain with new data, are you going to resubmit your let's say 510Ks or not? And there's open questions around that that's still not clear. But I think the FDA, that was one huge, let's say, hurdle. The other was around, I'd say, privacy and security. Security is becoming such a big factor in a lot of these discussions. So like we've had to move our infrastructure to be like a high trust or SOC 2 compliant. On the privacy side, every country we enter into, we spend, I'd say, like tens of thousands of dollars of legal fees to try to figure out how GDPR matches with certain local registration. So that we spend thousands of dollars on. And I'd say lastly is data integrity. It's funny, we hire machine learning engineers that they start first day and like, okay, great, I want to get started. I'm creating models. This is my job. And they realize, they spend 95% of their time probably just finding data, annotating data, cleaning data, structuring data, and it's just, it sucks for them because that's not what they were expecting,
right.
But it's such an important part of the job, and finding that really high quality expert data is difficult. Yep. And what's happening now is like the top 100 health systems are recognizing the value of that, and it's paying top dollars for that. Yep. Versus the other 3,000 hospitals don't know how to manage that, and it's about, from our perspective, trying to find the biggest bang for the buck of saying, hey, how can we work with you to use your data and give you the service that you want? So, and
then hopefully port that to those other health systems that don't have that infrastructure in place.
Exactly. But it's interesting, in our EULA, we have certain terms and conditions that say, hey, if you're going to use this product, you have to like leverage the data and share the data within the network, and every lawyer scratches that off. And then it's only when you have a discussion and I have to get on the phone and say, that's part of that, that's the idea. We're discounting the price because of this shared responsibility and learning. Yeah. So that's been interesting. Yeah.
Fantastic. Well, I know we have a few minutes left. Any questions from the audience? All right. If not, I have a question. I know we also heard this in other sessions, this whole question of automation versus augmenting, and I'm sure you get this a lot. I think I've been seeing a lot of press around radiologists are going to be obsolete in as few as 5 years. Any thoughts on this? Should we be telling our radiologist friends to start finding new jobs? Sure.
I'd like to get a quick poll to answer that actually. How many of you would actually get in a self-driving car today? So I'd say about 60%. How many of the room would actually get in a self-driving 747 with no pilot in it? Wow, that's good. I'd say about 30-40%. How many of you would actually...
We're definitely at an MIT AI conference.
Yeah. How many of you would actually get your next scan diagnosed automatically from an algorithm? Wow. So I'd say 50 to 60%. So what that was supposed to show you is that when the risks are higher, I think people need that personal touch, right. And I think it's the same thing in imaging. I think this is maybe a biased crowd.
Yeah, I was going to say we might have some selection bias here.
But I'd say 90% of what a radiologist does today could potentially be automated in the next 5 to 10 years, but there's still that 10% that will never go away. So potentially there'll be a reduction in force, but I think that there's so much to do.
Or maybe an upskilling.
Yes.
of the existing force.
Yeah, exactly. So there's, I would say right now it's complete augmentation, but it's still years away from, let's say, replacing.
Yep.
Yeah.
Great. Please.
I've heard that Epic has quite a monopoly on the data space with healthcare records. Would you say you're a competitor of them or work with them?
Yeah, so the question was around Epic and they have had them having a monopoly on data. So, it's actually, they don't have the data. They provide the infrastructure to store the data, and it's actually open. Like, you can hire any engineer to just pull that data from that warehouse. And so at the end of the day, they have a control on the market for sure, and they're the EMR, EHR, and we're more on the PAC side, so we're not a competitor. We embed in our information into their systems, but Epic is growing substantially, and they have a huge presence in the US, less globally, but they are a force, and working with them and to try to extract that data, understand it, structure it, will be important for all of us, because it's so much rich information in there that we'd love to combine with imaging and other sources to kind of move us into predictive analytics.
Yeah. And I might just, I think it's really going back to the initial point of working within the workflow. Mm-hmm. And whether it's Epic or any other electronic medical record, it's really about how do you incorporate the technology so that physicians aren't having to bounce around to multiple systems. And does that seem fair to you?
Absolutely. Yeah. And they want one system, one screen that does it all.
Exactly.
Yeah.
Even popping into a separate window, all of a sudden you start losing people.
Yep, exactly.
And developer experience is terrible and legacy. Have you found that to be true?
Yes, absolutely. There's companies, two or three that come to mind that actually try to extract one level higher and give you a generic API that works with several of the big vendors. And so if you're a startup, if you're working with data, I suggest going that route than trying to work in their archaic formats on how to pull that data.
Great. Well, thank you so much, John.
Thank you.
Oh, great. Excellent. Well, Ash, thank you so much for joining us.
Definitely.
So we just heard a very concrete application of healthcare, but maybe just to step back a little bit, tell us a little bit about your experience in terms of bringing AI into healthcare. Why do you think there hasn't been broader adoption yet, and why might healthcare be ready for it now?
Yeah, I think the notion that healthcare being ready is a question of where they are as an industry, but I think the notion of AI in healthcare has been around for, I don't know, from time that I can possibly remember, which perhaps is not too long ago, but nonetheless. But why now? If you really think about it, we're at actually a very interesting inflection point with respect to the industry. The amount of data that we actually now have actually captured in a form that's digital is actually extraordinary compared to where it was 10 years ago or 20 years ago, right? We have literally 10x to 100x amount of data on each person, right? And so secondly, we actually now start having the computational capability to handle the complexity of healthcare. Healthcare, perhaps more than almost any other industry out there, is the most complex, right? Simply the dimensionality of the data itself is just vast. And so without sort of almost the newest, the best sort of computational capabilities that we're talking about, we simply did not have a way to systematically address that level of complexity. And also having the compute power to do it in time, right? It's an issue of speed. How fast can you take that piece of data, that new piece of data, interpret it within the context of that individual, and come back with something that's usable literally within milliseconds, right? And so, we have across these different things, from data, from computation, from communication, to I would say the economic reality that actually now creates all sort of a confluence of reasons as to why AI now in healthcare actually is now going from an idea to a nice to have to now an imperative to actually be successful in the 21st century.
Yeah, that actually brings us nicely to your company, Lumiata. So can you just tell us a little bit about it, what the mission is and what you're focusing on?
In some senses, it's we think about changing the lives of people one future at a time. And really it's about how do I combine medical science with data science to really be able to predict what is going on with the individual right now today with respect to their health, but also financially, how that's actually going to progress and why and what you can do about it. Right? When we think about the industry overall, we think that people ask sort of three core questions which sort of drive the overall industry. The first really being, where is each individual's health today and how is that health going to progress over the next year, 2 years, 5 years, and why? Secondly, what's it going to cost and why is that happening? And lastly, what can we do about it? And if you think about it right now, the machine that we have that does this right now is called a physician, right? But unfortunately, physicians are not that scalable, right? They're not going to process 2 million people in 2 hours and give you an update as to the view of across the people and immediately reprioritize who they're engaging with. I mean, both my folks are physicians. I grew up with hundreds of physicians. I love them, but that's just, they're not data, right? Towards the point, right? So it's interesting why that was the case, and sort of seeing this sort of continued growth, not only from the episodic data that we have from claims and labs and EHR data, but actually start when you move into the basically sensor data, right? When you're talking about much higher velocities of data coming in, much higher frequencies. And really think about that, combining that with genetics, right? The simple amount of data that you're going to have about a person and the potential nuances of how those pieces of data combine and the complexity just starts becoming overwhelming. And just like the microscope sort of reinvented medicine, as we can say, last century and the century before, AI is sort of the microscope of the 21st century. It's allowing us to create a completely new lens into the data and the lives of who we are. And in some senses, we're trying to say, what is the story of each of us today and how that story is going to unfold and what are the ways we can impact that? And that was really sort of the motivation of Lumiata, was how is it that we can go ahead and take the knowledge that we have, take the data that we are generating and capturing, really create a way and to create that sort of core self-learning modeling platform, right? Where it's not talking about a particular condition or a particular event, but really providing the framework to do all of it across the board and do so in a way that's robust, so that actually when you deliver value to people, it is indeed accurate, it is indeed rigorous, and you're delivering value every day for people.
And you actually have developed that risk matrix today.
Exactly. I mean, in some sense, we think about, risk being the flip side of health, right? So if you can minimize someone's risk, you can maximize their health. And so what we're really trying to do is understand at a financial level, at a clinical level, and then, what is going on with each of these people and how does that interplay? One of the things that we found most interesting is both parts, being able to understand the financial outlay of somebody as well as the clinical outlay independently are necessary, but only when combined become sufficient to actually drive the business and operations. Because really what you're trying to do is understand every day for the resources that I have, where's the biggest bang for our buck? And really creating that platform, that AI self-learning platform is really sort of what we've spent the last 3.5, 4 years building. I mean, because as I said, healthcare is complex, and to really handle the spectrum, you need something that was actually very robust to do that. And so we're very excited by what we built so far, and obviously looking forward to seeing how we can hopefully make each of our lives better.
Yeah. Well, and so this idea of developing these risk models is something that health systems and payers have been investing in for decades. And so how do you feel like, what do you think AI and machine learning is actually able to do to really transform that beyond traditional risk models that people have been investing in?
Yeah, I mean, look, at the end of the day, the healthcare industry overall has been built or is actually in existence to help us manage the risk of our health, right? And so when we look at the overall ecosystem, and it's interesting sort of where payers or health plans fit into this, they're actually the interesting place where you transform, where from money gets transformed in the bounding boxes of how care is delivered. So they're a very interesting place to saying, as you make shifts there, you have the opportunity to positively impact the lives of millions literally the next day. And so for us as a company, as me as an individual, that's super exciting, right? And where AI really comes into play is we find that these people are very data rich, but you can sort of say insight poor, right? And so they have not been able to really take advantage of all their data assets. They have huge amounts of it, but we talk to them and they're like, but we don't use it. And we find it's true because if they did, they would have corrected all the wonderful errors that we find in their data. But what AI really allows them to do is, one, now take advantage of that much higher spectrum of data, right? So the number of variables that can be taken into account. So like one of our most recent things that we're doing took into account like about 126,000 potential different features for what's going on with the person to really accurately predict how their utilization is going to happen, right? And so I think what we are able to do is show them that with even the current data assets they have, they can be transformative for their current operations, because AI is able to truly extract that signal from the noise, right? So how do you go beyond regression? And that you're learning actually every week and every day as new data comes in, right? So
Sure.
you're always getting better as you get more and more longitudinal data.
information, yeah.
And that I think is also very exciting for them as well.
Yeah, so I mean, definitely, I think a big theme is data, data, data. And one thing is that, just as a simple anecdote, I was talking to a health system CIO recently, and so he had kicked off a project where he's working with a vendor to come up with a predictive model to identify which patients were progressing with chronic kidney disease, to try to get ahead of that.
Yep.
And the vendor came back and said, here are the 10 things that are very predictive of this progression. But then when they tried to then push that forward to the rest of their patient population, they found that only 10% of their patients actually had data on those 10 factors. So it wasn't actually, it wasn't easy to apply. So are you seeing that as well?
Yeah,
and how are you thinking about that?
I think that's the ever challenge in healthcare, right? Is, if you think about, first of all, let's just take about the health data challenge overall, right? You think about ICD-9s and ICD-10s, which I'm presuming everyone in the audience here is unfortunately very familiar with, and just the fact that that in of itself is sort of an end-to-end map right there, right? So you already have this problem on the basic coding front that happens to be there. Secondly, it's a very stochastic reality, right? You only get data at particular episodes of people, right? And so, and then in addition, many of the types of data that you would want that are at times very highly predictive or informative for any particular event and or condition at times is not captured. I was just I was speaking at a HIMSS conference yesterday, where we were talking about, I said, where's the code for lonely, right? Which is actually an extraordinarily important factor to understand how things may progress for somebody, right, in a variety of fronts. And so it's interesting how just the core data that one would want at times is not there. And this is a part where we spend a lot of time trying to think about this, because the data that's captured for people is actually not standard, right? You get very sort of high variability in the data you capture. And so this also actually surprisingly interesting from data set to data set, meaning from organization to organization that we deal with, you also see high variability within this data, right? So then you come to this whole point about how do you execute general models? How do you deal with this transferability problem, right? And this is really where knowledge comes into play, right? Because in healthcare versus in other industries, other industries has very tall data, right? You'll have billions of examples where you go and have that, and you'll have maybe a couple hundred or a couple thousand variables. In healthcare, you may have a couple million examples, or usually actually a couple thousand examples, but you'll actually have millions of potential variables. So it's a very sparse data set comparably, right? So what we've really found, and what I think differentiates Lumiata quite a bit from what's out there, is we leverage knowledge to actually address this problem, right? Because if you think about knowledge, that is our accumulated understanding over hundreds of millions of people over hundreds of years, right? And then how do you take that and apply that to that raw data to really aggregate and abstract the information just like a physician would, so that you're actually making the signal apparent for the machine to actually learn. And we found by doing that, you get a huge bump in actually the performance of what you're doing. So it's really not trying to invent, let's try to invent a new Kyruus or TensorFlow or things like that. I mean, people are doing amazing jobs of that, right? Really, it's about, towards the point, garbage in, garbage out, right? How is it I can deeply, deeply make better that which I represent more intelligently to the machine, so that therefore I get a better outcome, and then how do I take that output and actually do a much better job otherwise? And so that's sort of our addressment of this, is sort of leveraging knowledge to address this data gap problem, right? And then we also try all sorts of different ways to give at least better baselines for things, like, leveraging census data, leveraging every other piece of data we can, so that we can create better sort of, I guess, ranges of information about people, so that we can go ahead and reduce the overall error in what we're predicting.
So you're trying to help to use public sources or other external sources to try to fill in some of those gaps.
Exactly, everything we possibly can.
Just throw data at the problem.
Yeah, and hopefully in an intelligent way, just not randomly, but yeah.
And so then how are you seeing this translate into practice? How are you envisioning this will impact providers, workflows, and actual patients? I know we were talking about that earlier as well.
I think when you start getting this transformative amount of precision with respect to on a per condition basis, or respect to just, healthcare as a business, the financial side of it, right? How is it you can really show people with a much higher degree of accuracy where those costs are going to be and why they are. You actually change the way the fundamental processes are working because you're helping them reprioritize where they're applying their resources, right? It's kind of funny and to say, but healthcare kind of runs on lists, right? If you actually think about it, everything from care management, quality management, risk adjustment, underwriting, claims administration. At the end of the day, people are working on lists. And if they're not working on optimal lists, you're basically getting suboptimal performance. And by creating transformation where you're actually enabling them to generate much better lists, you're actually getting them to have much better results. But towards your point of workflows, right? I mean, we talk about processes, we talk about lists, which automatically impact workflows, but then we can also talk about the workflows themselves being smarter, right? In some sense, the way I think about EHR is sort of death by checkbox, right? I mean, they provide you the literally 10,000 options that's supposed to be potentially relevant, if at all. And that's true, unfortunately, that you have to do that because there's huge variability. But if you had a system in the background, and this is an idea that I've had for a while, is such as what we do, can you actually pare down that 10,000 to the top 10 that with a 90+ degree of likelihood really cover your span, right? And so therefore, just from a simplicity of use perspective, you then get much greater likelihood, much better interfaces, et cetera. So I think AI is this ability to sort of unlock the capability in healthcare, one from better ways for physicians and nurses and the system to interact with the data, but also for the patients themselves to be able to intelligently interact with that. But if you think about that, also moving that not only from the front end, but all the way to the back end, right, where you have this ability now to, how can you align what we all intuitively understand is the mission of healthcare with the business of healthcare. And I think that's where AI comes into this option of it has the ability to help align the mission and business of healthcare because it can provide the granularity that's needed on all sides so that people are able to do the best possible for each person to help them basically live better lives. And so, that to me is what's exciting.
Yeah, especially in healthcare, where as many folks know, the incentives are often misaligned across different players.
You're right, and and in a lot of ways, you have this, I guess, point places where people are obviously very happy with that. But in the whole, I think people recognize that we have a misalignment, and all this efforts that we're trying to find from value-based care models to otherwise, it's an attempt to figure out how it is we can actually construct a way to align these two things, the mission and business of healthcare. But in a lot of ways, it's not a political solution or it's not a thing. It sometimes is a capability solution, right? If you're not able to have that granularity, just like we didn't have the microscope before or other things, unless you're able to have that granularity and be able to do so at a certain level of speed and accuracy, some things are just not possible, right? But now with AI, I think we are able to start crossing those thresholds, to actually with that level of accuracy that we need, they can actually start driving that ability for us to generate models that make sense, that create that alignment.
And besides just getting better and better data, do you feel like there's other advances in AI or technology that are necessary to get us to this point?
Yeah, I think I would sort of take it two different ways. You can talk about the very technology side of things, like looking at long LSTM networks, which is, a little bit dated, but basically dealing with how do you deal with very long temporal signals and looking at ways of dealing with that. And I think some very interesting advances with that, with what's going on. But what I think almost otherwise, what's also very interesting is AI's ability to surface or make signal from data sources that we didn't have before. So I think about voice and audio. I think about video. You can talk to a physician and say, "Hey, I looked across the room and I just knew that guy was going to crash in 20 seconds." Well, that's really interesting, right? What's up? That seems to be something that or I was just hearing someone, I knew they were depressed, right? So it's an issue where you start looking at AI to really surface data that otherwise was not able to be structured or identified before, which therefore starts allowing us to create a much more holistic picture of an individual and then really be able to make use of that collectively to do that. So to me, it's not just the simple techniques or whatever, but the ways in which AI can be leveraged to really take what we all experience from our auditory, visual, so on and so forth, and really surface those in ways that can be then combined with the structured and unstructured information we have with healthcare to really generate a much different picture of an individual and therefore be able to engage forward.
Yeah, no, one of the other speakers was talking about how when you think about a cardiologist, there's a loss of information from when the cardiologist looks at the image to then processes their response to that image to then actually writes a report that other physicians or nurses can process. And so that flow, you're losing information along the way. And so I think what you're talking about.
Yeah, and when you're engaging with when a physician's getting, or a clinician or nurse, whoever's engaging
Absolutely.
with the patient, that doesn't get transmitted. That's not recorded. And there's so much that's actually not recorded.
Right.
Right. And so, yeah.
Yeah. Well, I want to open it up. I know we have time for maybe a couple questions.
Hi, thanks for the chat. Nasser Banpuri. I'm a data scientist at Berta Health, and one of the things I work on is developing risk models for physicians so they can get a list of ranked patients. But then the next question I always get is, okay, so this person's at the top of my list. What do I do about it?
Yeah.
And do you have thoughts on approaching that problem?
Definitely. One of the things that we feel at Lumiata is really important is, the why is just as important as the what, right? So being able to explain why it is that someone's at the top of your list, what exactly is driving that. And that's a lot of what we've done is we've built a lot of things what we call sort of interpretable deep learning, basically models to make sense of models, right? So that therefore we can really explain this person is going to crash in the next 48 hours, or this person is going to be having congestive heart failure in the next 3 months. And here's why, what's driving it, right? Because the first step to understanding how one actually minimizes or addresses that risk is to understand what is actually driving that risk and to be able to do so. And this becomes a question then of, other types of data from things like social determinants and otherwise, because those are large signals that are important. Like, maybe this person is just not taking their meds because they don't have any transportation, right? So how do you actually surface that? Because that gives you the insight you need to actually start addressing the what to do for these person. So at the end of the day, what we really are trying to get to one day is answering what to do for whom and what works for whom.
Great. I think we have time for one more question.
Sure. So as you talk about variability As you talk about variability among the data that you're getting, to what degree can you train a model at one site and translate it to another site without having to retrain it individually for the site?
Which is the key question for us. We've now amassed, literally 60, 70, or 80 million, I forget which amount, patient records. And the core point here is how do you create transferability towards their point? And this is really where, you have to be able to abstract, and this is where applying knowledge to be smarter about how you actually represent your data becomes key. Because, for example, one system's formulary may be different than another. So the distribution of meds that are used are different. Not that there's a conceptual difference between what's going on, right? So how do you abstract this reality from the NDC issues and the different distributions to understanding truly what's going on, as an example. So this is actually one of the core things we focus a huge amount of time on, is specifically addressing this. Because otherwise, gathering more and more data is actually not helpful, right? Because if each model is just completely specific to that small data set, then I haven't leveraged the totality. And then our value to our customers is reduced, right? And so one of the things, our value is we actually have more data than most of our customers by a long shot. So I can sit there and say, yes, in your data, you may have 20,000 examples of diabetics. I have literally 10x to 20x amount of examples of diabetics. So what I can bring to you is a lot greater value towards that. But it really is about how you represent your data to deal with the transferability problem.
Great. Well, thank you so much, Ash.
No worries.
I know
Thank
we
you,
probably
everybody.
could talk to you for a lot longer.
Thank you so much.
You are very passionate about this topic, particularly around open data and interoperability. Particularly, there's now, as Ash was mentioning, just this proliferation of data from not just traditional sources like claims and EHR data, but now wearables. There's data everywhere. So can you tell us a little bit about what you do at Google Cloud?
So I'll answer it in two ways before I say what I do. People know Google as a consumer company, but in the essence, we are a data company. For past 18 years, we've been building Google products that serve billions of users. These are products which are consumer focusing, like email, Gmail, search, Android, maps, and so on and so forth. What's interesting is they serve a billion users each, but not just the scale, it's the infrastructure that is underneath is what powers all these core products. And what we found out was what we deeply care about running these products ourselves is what our enterprises need to build their businesses, to do their transformation. So that we are now working with our enterprise customers very deeply, and that's what we call Google Cloud. So within that context, within Google Cloud, I run the solutions. And one of the primary area of my passion is interoperability, which is data liquidity. And it is actually important for all of us. I'll ask a question. How many mobile apps or digital experiences do you think exist for digital health today? Healthcare apps. And this could be iTunes.
3,000.
Higher, much higher. 187,000 the last I checked. Right? And there's an app for everything. If I'm diabetic, I have an app. If I have high blood pressure, there's an app for everything. But now let me ask you a different question. How many of these apps do you think connect to your patient record? Right? 2%. Right? So that's
higher than I thought.
Actually, true. So these are more the HR-led apps, but that's 2%. We as consumers will be better served if these apps, these experiences can connect to our own data with our consent that I will give. And that's the passion, that's the area in working with the EHR, working with our clients to making that possible. And it actually also makes business sense. I'll give you an example. So coming back to my role, so I work with world's largest healthcare organizations. These are payers, providers, pharma companies, and understanding their digital transformation, their AI journey, and building solutions, taking the Google tech, be it AI, be it APIs, AI, and solving in terms of an industry use case in that context. So one of the providers I'm working with, Cleveland Clinic, they have powered their entire e-hospital. Like when we all talk about cost, right care, the right setting, can we give telehealth capabilities? So they built the e-hospital, which is monitoring all the cardiac care units, and the data is flowing by APIs. And then physicians on they call ICU bunkers can place orders, we connect to Epic. All that experience is possible because that app is connected to the backend. Epic didn't build that app, right? Epic builds hyperspace, more physician focus. These are the new experiences, telehealth, virtual capabilities that will drive and access to care and lower cost to health. So examples like that. Another example they have done, how many folks have heard about Oscar? So at HIMSS, they announced the Oscar, which is an insurance, I call it healthcare unicorn, but they have amazing user experience for people to find insurance. They are able to connect to the Cleveland Clinic's appointment scheduling system, which is basically Epic Cadence at the back end through APIs. So if I'm a consumer, I'm searching through what's my best insurance, what are the doctors' availability, and today it's sometimes a very manual, you call, it takes 70–80%, you listen to the music, and then you book your appointment. So now that's what the power of interoperability comes in. And we don't want to reinvent the wheel, so I'm a big supporter of FHIR as well. So FHIR has scheduling as an example. If you expose it through that, then you're creating an interoperable ecosystem. At Health 2.0 last year, I showcased a Google Home device, again, connecting to the appointment system of your backend. So today, when my daughters use Google Home, it's give me a riddle, give me a joke. But can I book my doctor's appointment? Does it know the nearest clinic? Can I connect to the backend system? And all those voice experiences or mobile apps, to me, are experiences. But for them to be connected experience, you need interoperability. You need those APIs. So that's where most of the effort in the healthcare solution side is towards that.
And you're working with a broad range of healthcare organizations, so I can imagine that they themselves are bringing a lot of information and data to bear, from clinical data, claims data,
yes,
pharma data, et cetera. Are you also working with them to bring in other data streams? And so you mentioned Google itself is a big data company.
Right.
So how do you work with them to think about these, maybe potentially new data sources that these healthcare organizations haven't traditionally thought about?
Good question. So other solution, we are like Clinical Data Warehouse in Google. We have 84 plus public data sets already available, deployed on our BigQuery. If you want to combine the external data set, one of the challenges who needs to get the data set, you need your engineers to cleanse it, load it on your data sets and on your environment. What we provide right off the gate, these are where we are putting our engineering assets to build this public data set library. 84 of them are available. So I'll give you an example. Colorado Center of Personalized Medicine, they are looking into, they are one of our Google Cloud customer. They want to give the therapies based on the doctors want to understand you at the molecular level, your DNA profile, and see which therapies are working for you. And they have genomics data in that case, around their cohort of 100,000 of users, but they also want you to combine the weather data, the pollen data, like what impacts health. And much of, I'm sure I'm preaching the choir here, 90% of your health is actually environmental, the other factors, and then your EHR. So combining all that, so they were able to leverage that data and kind of build. And doing that, the leg up that they have, the leg up actually everyone now has with this cloud movement is democratization of infrastructure. You don't need to be building, wiring servers and getting the data, doing the grunt work. We are doing the grunt work. It's not very sexy when I say we get the pipeline and we cleanse the data. So we have, what we announced at TIMS was HL7 API, Fire API, DICOM APIs. So these are pipelines to your backend systems. So our customers are, so we're not doing it as a Google, we are doing it as Google Cloud, and our customers are doing it leveraging our platform. So big distinction where, yes, we're a data company, but in this case, the data belongs to you. What we bring to bear are technical pipes, technical solutions, because one of my jobs is to see what are the repeatable patterns. Why is this it's a first mile problem in the healthcare. Just getting the data to the cloud, connecting to the HL7 pipeline, and that's what we are building, those grunt work, those pipes. So DICOM, as an example, is imaging. Genomics is genomics API. So if I have to run a query like, give me all the females from the age 40 to 45 who have this BRCA as genomics biomarker, who's imaging for mammogram, connected to this metadata, and who hasn't seen a doctor's appointment in past 3 years, kind of combining that. So to run that query, you really need genomics, you need imaging, you need your HL7, which is your EHR, and combining that.
And patient appointment
Yes,
which often is sit in a different system.
Different systems, and within the systems also they don't talk. Right. So, but today it's possible to run that query, connecting those pipes, bringing the data to the cloud. To me, to do AI and machine learning, and I hear that a lot from our customers. Everyone wants to do AI and machine learning. Everyone. Right? It's like a pixie dust. Oh, can I get to AI? I'm like, no, first, let's solve the data problem first. To build your model, you need to get your data. I think that's where it becomes the cornerstone to do the next steps. It's a journey. First step, understand where your data sources are. And I have a healthcare background as well. So I was with Kaiser Permanente for 8+ years, 160 data marts, right? So, and we were one integrated system. And it's pretty complicated landscape in the healthcare technology.
And so, I mean, a lot of the big players are investing in this. Obviously, you talked about the API that Google's released recently. Apple has been all over the news with their medical records, patient records that they're exposing. How far do you feel like we actually are in that journey to getting to interoperability? And what's holding us back from getting further?
I think a lot of positive momentum, and it speaks to the broader point that we need to democratize patient records. Me as a patient, I want my own records, so different companies are angling and helping in their way. But the challenge remains, I call it one-on-one combat, right? You have to kind of convince the hospital system, why is it good? But there's reasons for that, right? Healthcare industry is a very inward-focused industry. And what I mean by that is, for multiple decades, the systems are built, they assume you to be in the clinic. So if I'm sick, I go visit my doctor. If I'm a little more sick, I go to urgent care. And I'm really, sick, then I'll go to ER. But they expect you to be in the system, in that physical four walls, wherever those four walls are. Now with digital, it's completely changed. It's care where you are. And for that, you need to kind of open your system, and systems are not designed that way. So I think that's the biggest thing. Security comes into a big way. And how do you open the data with the right security, right auditability, right accessibility, and they're right. And I think that paradigm shift of being from inward focused to imagining care wherever you are, and it needs that system thinking of building the right discipline to open it.
Yeah, absolutely. And especially given a lot of these new channels are also more digital channels.
More different channels.
So you are now incorporating yet another data stream into the EMR, which historically I've seen with telehealth vendors, for example, they're not always integrated into the medical record either. So you're now creating yet another shadow record in the patient's history.
And healthcare moves two ways, penalties versus incentives. So when EHRs came in 2009, do you know how much money was spent? It came from government, $32 billion, right? That was the movement. But here we are in 2018. I think 90% EHR is there. And now, in this, especially in the interoperability way, I think government is ahead. They are like President Obama when he said ACA, and the whole meaningful use stage 3 came in. That became that mandate for the hospital by 2018. Now, with President Trump, it's 2019 Q1. But they announced at HIMSS, Jared Kushner was there, Seema Verma, that interoperability is a big focus area for the government. And if by Q1 2019, it's called My Health Data Initiative. So I'm very pleased that the movement is coming, but again, that's the either incentive or the penalties. If you don't follow it, there are fines. If you are able to do it, they're incentivizing it. So I think to me, those are the big trends that will shape it, and I'm seeing a lot of hospital system and even EHR vendors. Epic has shipped their file server, Cerner, they're also looking into opening their APIs. And it's coming not just because from the goodness, yes, it's from the patients as well, but it's also that mandate and the policy. Everything has to come together, right? It needs the community.
Yeah, no, I think and we've seen that play out in history, in healthcare as well. When you have that top-down mandate with actual real dollars at stake, it does certainly change behavior and technology adoption. And I think a big part of why we have such adoption of EMRs right now is because of a lot of the policies that have been put in place.
Yeah, so we went from paper to now it's electronic. It's huge.
Absolutely. Now I'm going to switch gears a little bit because obviously a lot of our ability to be successful is making sure we have the right talent and the right talent in healthcare. And I know one of the other initiatives that you're involved with on your side, I don't know when you have time for this, is you founded an organization called Girls in Tech.
Right.
And so can you talk about that a little bit? And I mean, especially now when I think there's just obviously a lot of attention, as it should be, in terms of attracting women into technology and women into leadership roles in technology. How are you, can you just talk about that journey?
Oh, thank you. This is for 2012. I have two daughters. One is in high school and is in middle school. So when my elder one was in the middle school, and I saw that, she's also being very, avoiding math, avoiding science, and kind of thinking, oh, it's not for me. And I grew up in India, even though I was minority, I never thought like that. Like, it was okay, everyone had to get good grades, no matter what. Like, math is important, it just came in. So I'm like, wow, after so many years, and here's my own daughter. So I reached out to the school, to the principal, and created a girls-only class. Because first I tried to do with a common class, and most boys were raising their hand, they were gaming, and not to say that that's not a good thing. We need an equal access to all genders, but my passion is much more, it's like a personal journey for me to be here where I am, and can I share and give back? And seeing my own daughters in the same spot, and there's so many daughters in the world that need help, that need those role models. So I teach, I started my curriculum, it was pretty dated, like JavaScript and website, and now I'm looking into building some kind of an AI curriculum. And I need help. If you're passionate, please connect with me, because I think it's the right age.
It's such an important initiative, right? Yeah.
When I did math in school, I never knew that there's an AI application, right? But now, AI model is a mathematical expression of an equation, right? So when you're doing pre-calculus, I want to make the connection much more stronger now. And it's the right age. when you're in the last year of middle school or high school, can you learn the math and think the application of how this will lead to AI modeling, and it's actually solving problems like Ash talked about, right? So important and pretty passionate about.
Yeah, it's great to help them
Sharing.
connect the dots.
Yes.
So I'll open it up to questions. I know we only have a few minutes, but please.
You know, if you said that Google is a data company. If you learn that as part of my profile I'm prone to heart disease, would you surface some useful ads like going to the gyms, for example?
We currently do not do that now. But here's what I
That would be embarrassing for some people, I think.
But that's not my area of expertise. Google search team is better equipped to handle that. But I can tell you that I was very positively, impressed. You can say when we learned that there's a health search team, and their focus is when you're typing, as an example, I'm suicidal. So things that these links that they surface are 1-800 hotline. So it's not the ad focus, it's how can you help? And to me, it's taken very, very seriously if we see those kind of searches and we say, okay, this is the positive hotline in your local community that you can talk to. That part we do.
Thank you. I'm intrigued by the open health records, and I'm a big believer that that's the direction we need to go. So I have two questions with regards to that. The first one is, you're going to get this question, why did Google Health fail? The answer online is not, it's interesting. It says, yeah, they had a bunch of passionate users, but it wasn't enough to convert it into a sustainable product. But Apple is coming out now. I already integrated my app to it. So, are they going to be more successful? If so, why? What are you doing to come back into that space, if you will? The second one, now that you mentioned DICOM and DICOM APIs, I'm extremely intrigued by that. I mean, there's 4.5 exabytes of data just sitting in PACS systems,
Right.
and they're very expensive.
Right.
And I can't help to think that this is an area that Google can just dominate. I don't know if you could talk about that. So, yeah.
I would definitely say we can help them not dominate, but the vision is our strength. So I'll tackle a DICOM first. So as an example, most of our vision models came from, we built YouTube. We know when we're building the video, we want to be able to have intelligence to take the content which is not appropriate or not kids age related, and so a lot of expertise was built. So actually we excel unparalleled in vision in general in Google, not cloud, not healthcare, vision unparalleled, because we had to build that capability for our YouTube to be useful to kids, adults, and so on and so forth. And now we have taken that and we are helping in 3 ways. So DICOM API it speaks to the data liquidity to move data from your PACS over to the cloud and then connect with our machine learning vision models. AutoML, how many folks have heard of AutoML? Very nice. So AutoML is our capability where we are giving those, it's a UI-based tool, and we are first model that we have released is AutoML for vision. So meaning if you have a bunch of images and you want to, it's DICOM is more medical. At HIMSS I showed a skin rash, and there were 10,000 images. It was a demo. We got it from a dermatology clinic, and the model is able to depict it with 90% accuracy. And this was done in 2 weeks by a customer engineer. So our vision is very, very strong. AutoML gives you the UI tool, get your images. The baseline would be you need to have the label data and label images. What is a skin rash in this case? So I'm happy to connect with you on the DICOM. We have a very robust even partner ecosystem where we're connecting. Once the data is in the cloud, now you can slice and dice it, Live Unity, if you eUnity, the DICOM viewers, we are now connecting to it. So yes, getting the data to the cloud is important, but then you also need to bring an ecosystem where we can connect different apps to it. And we depicted the bone age. Some of our partners, you put the image of the hand, it's able to now then depict the age based on the X-ray image. So these are some workable solutions, demos, but tons of opportunities, tons of opportunities. So think of us as a platform to innovate on top on. Fantastic. The first question is, why did Google Health fail? I think so. I think there's a humility, right? Healthcare is complicated, it's complex, and no one company can do it alone. And if someone is saying that they'll do it alone, it's not the case. So I think our approach right now is very much more of enablement of the community rather than solving everything ourselves. So these tools that we're building are building for hospitals, payers, pharma companies. We want them to innovate, not that we will innovate. So I think that humility is coming from a place where we understand the complexity of the healthcare, and we want to work with a lot of you very, very deeply in making you successful.
Great. Any other? I think we might have time for one more. Oh, nope, I'm getting the hook. So thank you so much.
Absolutely.
He is the CEO and founder of Openwater.
Hello.
Good morning, or good afternoon, I guess now.
Thanks for having me.
Mary-Lou, you have a fascinating background from academia to Google, Facebook, Oculus, and now Openwater. Can you just talk a little bit about your journey and kind of what brought you to Openwater? And then we'll talk a bit about Openwater because I think it's a fascinating idea.
I quit my cushy job at Facebook because you only have one life to live, so I advocate it all for you. So I, at age 50, started another startup, my fourth startup, because I thought that everybody was missing something. It feels like I'm a consumer electronics person. I've just as way of background, I've invented, prototyped, developed, and then shipped billions of dollars worth of consumer electronics with full custom chip design on the hairy edge of optical physics for the last 20 years. And I just saw, every brain cell in consumer electronic it has been for the last 3-4 years really focused on virtual reality and augmented reality. And I thought that there was huge swaths of what could be done that was being missed. And so I decided to vote with my feet.
And so then tell us a little bit about Openwater. What are you focused on? What's your mission?
We are trying to put the functionality of a multi-million-dollar MRI scanner or any medical imaging system into a consumer electronics wearable. And this is a mock-up of what that could be. This, instead of that reads and writes. So you can put it, around your waist or line a hat, put it in a pillow, you name it. And it uses the very factories that make the chips that go into your smartphone. So we can do this at a consumer price point.
And so most people in the audience, do you know what an MRI is and what an MRI actually looks like?
It's a 2-ton magnet that fills a room. It's the most expensive room in a hospital. And this is PAD or CT, but in general, seen inside of our bodies in high resolution. And we're surpassing the resolution. I showed on stage last week at TED our ability to see through skull and bone to focus to not a millimeter, but we showed on that day 7 microns, which is the diameter of the smallest neuron. So that means we can read and write neurons, which has profound implications for brain-computer communication, but also brain disease, which affects 2 billion people globally and is the most expensive healthcare expense in any country, in every country.
So given that MRIs right now are, as you said, 2-ton machines, how is it possible that you're able to make technology that's leveraging, or products that leveraging that technology into such a small...
How does it work? So magnetic fields go through your body, and we image with them with basically radio signals. And it's interesting how we play with the spins of the electrons. X-ray goes through your body, gamma ray goes through your body. We image X-rays. But has anybody ever gone outside at night and taken a flashlight and cupped their hand around it? What color is your hand? Red. Red light, lowly little red light goes through our bodies. And I think I have a laser here. So here's a laser. I'll be careful with you guys' eyes. But here's the thing, you can see the laser on my hand. It goes through on the other side if we darken the room lights, but you can see a little glow, right? The issue is that the light gets scattered. And so if you can de-scatter that light and then scan out the body, which we figured out how to do, then you can leapfrog the 2-ton magnets and the other systems that you can only be in for a little amount of time. You can only have so much radiation. Our systems have less red. We use red and near-infrared light, benign near-infrared light. We descatter the light using something called holography, which won the Nobel Prize in Physics in the 70s because of the fantastic things it enables you to do with light. I happened to spend, that's what I did at MIT. I fell in love with holography as an undergrad, and I didn't go to MIT undergrad, but the Media Lab was starting when I was graduating, not to date myself, and there was a holography professor, and you could get a master's degree in holography at MIT, which I dug into. So it's an esoteric field. It hasn't done that well. It's been very hard to get a job in it. But what you can take a hologram of your scattering of your body and then invert that so that you can render the scattering of your body, you can neutralize it. And so that enables you to see through your body. So we can now do that because of the manufacturing process improvements in the lowly optoelectronic manufacturing of LCDs and camera chips that have been the process improvements, the Moore's Law process improvements that have been put in place for next generation virtual reality and augmented reality. And that namely is pixel sizes approximately the size of the wavelength of light. So you can modulate the waves and the wavelength of light and record holograms. And so that's actually been the case on camera chips for everybody in the world for the last 5 years. Everybody has approximately 1 micron pixels in their smartphones. The wavelength of near-infrared light is 1 micron, so there you go.
All works out.
Although we do custom full chip design. The problem is they're a little slow, so we've sped up those chips with some novel architectures.
And you were starting to talk a little bit then about some of the more tangible use cases then in healthcare that you're focusing on. You mentioned brain disease. Is that where you think you'll be starting?
I think we're working on healthcare and brain disease. So the best signal to noise ratio for our application by far is something that's red, because red light is absorbed by red. So there's this thing in your body that's red. Does anybody know what it is? Blood. So you can get pretty far with just blood. Like any tumor bigger than a cubic millimeter or two steals blood to metastasize and grow to try to kill you. So any tumor that's metastasized has 5 times the amount of blood as normal flesh. Our system, and it also absorbs infrared because we're warm-blooded and that's how we circulate heat. So we're really good at seeing blood, where blood is, to find tumors or to track them as they grow or shrink. So you can imagine a wearable at home to see how the therapy's going, or immunotherapy, or you name it. We're also good at seeing where blood isn't, like clogged arteries. So that's pretty cool. And the change in color of blood when it's carrying oxygen versus not carrying oxygen, which is exactly what functional magnetic resonance imaging does, but in a different way. They use a 2-ton magnet. We just look at the color change of the blood, and it just seems a lot simpler. If you look at what's happening with medical imaging, it's a very small industry, 20% improvement every 7 years, total market of 2,000, 3,000 machines a year globally. And how do you make a 2-ton magnet better? So we're just trying to say, look, one of the problems with healthcare is, it's gotten a lot better, but it's gotten a lot more expensive. And so one of our jobs as technologists is to make it better still and drive the cost down. And to do that, I think we need to leverage the consumer electronics manufacturing infrastructure, the $1 trillion manufacturing infrastructure in Asia, which isn't that busy because everybody's got smartphones, it's saturated. So can we use those factories to do something different? And that's what we're doing at Openwater.
And so how does that translate to patients and provider experience where, is it that patients won't have to go into and schedule an MRI appointment, sit in a waiting room for hours to get that image, or how do you see it playing out in practice?
Sure, you could just buy the thing and have it at home if you want to go. But for example, there's 2 major kinds of stroke, the type caused by clots and the type caused by rupture. If you can assess what type of stroke it is within an hour or 2, you can give a drug to massively minimize damage to the brain. But if you get the drug wrong, the patient dies. So today, that means access to an MRI scanner within an hour or 2. They're too far from the hospital, tough luck. Tomorrow, with compact, portable, inexpensive medical imaging, every ambulance and clinic can have one of these things. So you can assess what type of stroke it was and deliver the right therapy in time. So that's one example. Another is photodynamic therapy. Like there's a saying that sunlight is the best disinfectant. It's literally true. You can kill pneumonia in lungs by delivering light. You can reduce chemo doses by 25-fold by delivering light therapy. But there's no way to do that non-invasively. You can cut the person open and sort of put a flashlight in. But we enable focusing through skull, flesh, bone, you name it, with light non-invasively because we're able to descatter the light. So that seems pretty promising. There's 2/3 of humanity lacks access to medical imaging. So compact, portable, inexpensive medical imaging could do enormous good because medical clinics now need a power plant, a 2-ton magnet, liquid helium, and then the shielding. Anybody walking by with a smartphone goes up against the machine. It's an amazing technology. It saved my life. I'm not, but it's too expensive. And then there's brain-computer communications, which is a whole other area that we seek to enable. Yeah. For brain disease. And just right now, the input to our brains is pretty good. We see, we hear. The output is basically moving your tongue and mouth and typing. Like, what if we could dump the images we think about? What if we could dump, the music? What if we could communicate with thought alone? What would we be capable of? And then what are the rules we want to put around that? So we're trying to think about what it means to be responsible and releasing that onto the world.
No, I think it has incredible applications for rural healthcare, not just in the U.S., but all over the world.
Yes, definitely. Globally.
Absolutely. And so one other thing I want to pick up on that we were talking about is the impact to communications and being able to communicate by thought. And so I remember reading that part of Openwater's mission is a moonshot to telepathy. And so can you talk about that and just what you're envisioning in terms of being able to transform communication, human to human, human to machine?
Right now, if I throw you in an MRI scanner for an hour, I can tell you if you've got a tumor or something. If I throw you in there for 10 to 100 hours, as has been done for the last decade by dozens of research groups globally, I can tell you what words you're about to say, what images are in your head, what you dreamt of, whether you're in love or not, what you had for breakfast, and on and on and on. And that is with 10 cubic millimeter voxels of oxygen use in your brain. We showed on stage live at TED, don't believe me, that's why I showed it live. Like, okay, look, this stuff really works. 7-micron focus, right? Or 5 micron, we can do any kind of focus. What if and that's to neurons, but even just, upping the resolution and lowering the cost can enable us with all of that data, machine learning, AI, to be able to communicate to the computer, to each other, with more sophistication than just language, to transcend language, to get the raw emotion out or what have you. And so we're enabling that. That's extremely important for somebody that's 40% of people that are brain dead, thought to be brain dead, are not brain dead. They're basically buried alive. Or, my grandfather, my father suffered from strokes and they couldn't communicate orally very well. Do enormous good for people that are unable to communicate in language. And also enable, can you imagine a personal tool for creatives to be able to maybe even unplug that computer from the internet because you put on the sex and violence filters. Like there's all of these issues, ethical issues. Like we create this, ski hat made out of this. Can the police make you wear it? Can the military make you wear it? Can your spouse make you wear it? I know a lot of guys that are scared of that, which is funny because I don't know that many women. So it's like, she might know that you're thinking about sex sometimes. And then can you put it on your child? These are just 4 basic. I would say the question is no, 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 no. And our system will only work with consensual use. Exactly. However, there's this thing when you make consumer electronics, and they call it the sincerest form of flattery. And so we're really trying to, one of the reasons I decided to do this in a startup is so that we could talk about that. And we're working with lots of different ethical groups globally on trying to define, to show this is coming sooner than most people believe, or at least we believe this is coming sooner than most people believe. And what do we want to do globally to get ready for it, to define what it is to be responsible?
And what does that journey look like? Do you feel like all of the technology components are in place and it's just a matter of working through it, or do we need
developer kits in a year? We'll start production on the health side and probably the oxy-deoxy first. I don't think we're going to read and write neurons for a while. We're probably going to hold off on that because that's such a big step. But we can do that and are doing that in our labs with the same components. And so there's this disbelief, I think, that how close this is and how it leverages existing factories that I've lived and breathed in for a long time, for decades. And so, yeah, I mean, I don't know, we're trying to figure out how to do it. And the norm is good for healthcare. I nearly died when I was a grad student because I'd actually dropped out of my PhD program in physics to go home and die because no one could figure out what I had. I was living in a wheelchair, I was sleeping 20 hours a day, my body was covered with sores. I could no longer subtract, so I didn't think that I deserved a PhD in physics. And so I dropped out, went home to my parents' house to die, and then one of the professors from the med school sprung for the cost of an MRI. They found the brain tumor. It only took a month to have the brain surgery and to petition to get back into the PhD program, and I got the empathy vote because I had a brain tumor. And it works if this ever happens to you. And I finished my PhD in 6 months, and we had 2 other students. We got $4 million to start our first company. So that was 1995, off and running, 4 companies later, executive positions at Intel, and Facebook, and Google. And I was a professor at MIT too. So like, because there's a stigma, I just told you I had a brain tumor, so I'm like, there's like, are you still smart or not? And in fact, everybody here is brilliant.
Sounds like yes.
So. But yeah, you can recover from all of that stuff, but if you can find it and treat it. But so much, it feels like 80% of the time when you present with symptoms, it's these 4 things, and then 20% of the time, it's these 4 million things. And so many people suffer with suboptimal, functioning because we can't find out what's wrong with them, and they suffer for many years. And with better diagnostics, and there's all this omics work, but lower cost medical imaging and more convenient so that you can compare this month's image from last month's image or this year's image from last year's image and just see the change. We can't do that right now because all of this stuff is so expensive.
Right. See the change and the rate of change.
Yeah,
exactly.
Well,
I'm going to open up for questions. I'm sure there's a lot. Good.
So when imaging becomes ubiquitous and cheap and available, it sounds like we have a solution to what all of our radiologists who are now displaced by AI are going to do. Do you see AI as coming in as a place where that, where the proliferation of images and data starts to be able to process that to something that's useful to people?
Of course. I think that radiologists now should reconsider their profession. They're killing people because the AI is better. But yet, 3 continents do not have enough doctors. They're doctors too. Like, we can put them to work. If the AI is better at seeing the image, what is this fight about? But I must be naive because it must be more nuanced than that, and I don't really understand why. I think radiologists are killing people.
Do you have a connection in your business plan to move that?
Oh, of course. I thought that part was the obvious part, the AI machine learning. What's new is that we have more data, because everybody in every talk I've said is like, whoa, how do we get the data? We have a lot of data because we can make this thing. So we leverage that in the AI machine learning stuff. But yeah, sure.
I have a more broad question. We've seen a lot of startups working on software, AI, and I wanted to really get your opinion on what the challenges are raising funds for hardware startups.
So the question was challenge in raising funds. So I've had no problem whatsoever. I didn't have a business model and raised my seed round over a year ago, and it was sort of interesting. Last week at TED, I gave a talk, and there are all these VCs. Anyway, I'm trying to decide which money to pick, what the smart money is, but there's a ton of interest in, I think here's the thing is, if any of you are considering this, I was actually talking to a very famous AI person last night, and that person hasn't announced what that person is doing. I was very clear not to reveal their gender. You know, like, if you've got a track record, like, I think there's 1/3 of the number of startups starting now than 2 or 3 years ago, and there's like 4 times the amount of money. There's a lot of money out there for good ideas. And if you're frustrated in the bigger companies, there's big companies that are paying really well, and like once you've paid off your mortgage, maybe, and you know you've learned something, and they bet on somebody else, because usually they're filled with everybody at Google's overqualified, or like, so you might want to. And I loved working at Google; it was really great, and hung out with Sergey last week at TED, and that was great. But like, what do you want to do? This is it. This is your life. And maybe it's easier to do it in a startup construct. I think it's pretty easy. There's a ton of money out there right now for things. And I think it's pretty easy to raise money for hardware startups, despite, I think I saw a panel yesterday saying nobody was funding hardware. And then, I think every single one of them came up to me wanting to hear my pitch. So I don't
So you
think they
say
really
the good
mean
idea,
it.
good team, good track record.
I don't think they really mean it. It depends what. I don't know. I mean, it seems easy. It'll probably get harder. It's easy right now. I'm usually, so for context, my last company, I closed Series A in Q4 2008. That sucked. It was awful. Like, on Sand Hill Road, like, the lights were on, the drinks were free in the fridge, but they weren't due. I think I was the only Series A that closed in Q4 2008 on Sand Hill Road. It was brutal. So I'm used to raising funding when, like, nobody's funding anything. And so right now it seems like really easy. And I've never actually experienced easy fundraising, but this is, to me, easy. But maybe this is normal, and I've only known just famine.
So good idea, good team, good track record, and do it now.
And timing, yeah, timing. It's a good time to raise money.
Great. Question?
Yeah, I'm curious to hear a little bit more about the brain kind of computer interface that you were talking about. So it's not clear to me that the human brain, oh, here's a microphone. It's not clear to me that the human brain, excuse me, I'm stuttering, that the same thought gets manifested or represented in everyone's brain in the same way.
Right.
So how do you actually encode that when everyone's brain is probably like a little bit different?
I think data, AI, machine learning, right? Clearly, certainly the studies that have been done at the dozens of research groups using fMRI and implants, but the implants are, I had non-optional brain surgery. I just don't see 1 billion people. It was the hardest thing I didn't realize. I don't see 1 billion people doing optional brain surgery for implants, let alone the privacy concerns of how to take them out when you want to have a private thought. So how does it work? How similar? With the fMRI studies, it turns out, I talked to lots of professors, and they said, they started testing with mice, then they moved to rats, then macaques, and now they use graduate students. So graduate students in neuroscience throughout the world actually have pretty similar brains. That's not to say everybody does. But certainly, if you put this thing in your pillow, you can get, lots of training data on it pretty quickly. So that's just oxy-deoxy. Again, we can get the neurons as well. And it seems clear that those are the building blocks. Oh, and you should add in hormones and neurotransmitters as well. They profoundly change how we think. I was at the National Academies this week for a session on real eye and AI, I standing for intelligence, and they brought in hormones, and it was great. They had this group of mice that were monogamous, and then they injected them with vasopressin, which is a hormone, and they all became promiscuous, which is like, this part isn't entering this discussion of AI and real eye, and the hormones really do affect our behavior, and we like to think it's about the logic level, but they bathe all of your neurons in different chemicals and make them fire in different ways, and on a mass scale change your behavior. So I think all of that's being studied. We're just making really a new, better tool that's dramatically lower cost that can enable us to learn even more about how our brains work. And oh, and by the way, we're not the only thing with a brain on the planet, not just humans, but there are all these other things with brains, and we may be able to communicate with other animals as well as we think about the implications of just the building blocks. What are the neurons doing? What are the neurotransmitters doing? How's the oxygen use? If you can get those, store it, and mine it, the question is, how far does that get you, and what else is missing? Is it like, the second brain, your gut? There's always will be more, but we don't have that right now in any kind of resolution.
Wow, well, fascinating topic, and I think we are unfortunately out of time. But thank you so much, and very excited to see all of the progress ahead.
Thank you.